Hello everyone, welcome to ashatech.com, your engineering sciences channel. In this lecture, we are looking at the bearing selection. The guiding question says a single row deep groove ball bearing is subjected to a radial force of 8 kilonewtons and a thrust force of 3 kilonewtons. The shaft rotates at 1200 rpm. The expected life L10H of the bearing is 20,000 hours, and the minimum acceptable diameter of the shaft is 75 millimeters. Select a suitable ball bearing for this application. The dimensions and static plus the dynamic load capacities for a single groove ball bearings are shown as below. We have the internal diameter or the inner diameter, the outer diameter, and the axial width of the bearing, then the basic load ratings, then the designation of the bearing with the diameters that have been chosen, and we have the 75, which is the diameter being talked about in the question that we are providing. Then we have also other constants that we need to look at. The FA divided by C naught. FA is the axial load, then C naught is the basic load at rest, which is the static carrying capacity, the static load carrying capacity of the bearing. Then FR is the radial load. So FA divided by FR is greater than E. If it is greater than E, then always the value of Y will vary, whereas the value of X is a constant. Now, what is provided is FA and FR, then N is 1200 rpm, then L10H is the 20,000 hours, which is the rating of the bearing, the life rating of the bearing in hours. Then the equivalent radial load is P equal to XFR plus YFA. X is the radial load factor and Y is the axial load factor. Now the X and Y factors are obtained because if we find that the bearing is subjected to both radial and the axial loads, then we need them, because at the end of the day we need to determine the equivalent radial load. So if we need the equivalent radial load, it is a combination of the radial force and the axial force, which we have to determine basing on the factors X and Y. Now these X and Y are provided always in the table and can be reached out by or decided on by trial and error method when FA out of FR is greater than E. Now we have seen that the values of Y vary from 1 to 0, and the values of X are constant. Check here, you see the values of Y change from 1 to 2, whereas the values of X are constant. So if we took the average value of Y to be 1.5, let us start from there. So when we start from there, we substitute in this formula for the equivalent radial load. Then we later on substitute in the formula for the the dynamic load carrying capacity of the bearing, which is P times L to power 1 out of K. L is the load, is the life rating of the bearings in million revolutions, and K is dependent on whether we are talking about the roller bearing or the ball bearing. If it is a ball bearing, it is K is equal to 3. This is a ball for ball bearings, and K is equal to 10 out of 3 for roller bearing. Okay, so we need to determine L, which is in million revolutions, and that will be the expected life in million revolutions. That will be 60 times N times L10H in hours, then divided by 10 to the power 6, which gives us 1,440 million revolutions. So of which we substitute in C to get the dynamic load which will be 8980. Of course, after substituting in this, we will get this value, which is the equivalent dynamic, equivalent radial load. Then we substitute it in this formula, we get 100,000, then 406.043 newtons. That's the dynamic load which we are going to use in selecting that particular bearing. So we come to this table and we look at the 75 millimeter diameter. Then down there we look at C, which C is close to 101,000, and this is 112,000. So we also take the C naught. So we take this and it's C naught. So when we take that value and C naught, then we need to calculate for FA out of C naught, then FA out of R, and this is 0.375, this is 0.0417. And that means we need at the end of the day to calculate for the value of Y. Which value of Y? We are now looking at the exact bearing, and so we will need to determine the value of Y that will give us the equivalent radial load which this bearing is going to carry. So the values we have, we know FA out of C naught as 0.04, when the value 0.04, we have calculated it as 0.041. So when we go to this table, we find that 0.041 lies between 0.04 and 0.07. So therefore, we need to calculate for the value of Y that corresponds to that particular FA out of C naught. So the Y also lies between 1.8 to 1.6. So what do? We go and use that information to calculate for Y using linear interpolation. This is 0.07, this is 1.6, and this is 1. So by linear interpolation, we are able to calculate Y from Y minus 1.8 divided by 0.0417 minus 0.04 equal to, this will be 0.0417. Okay, this will be Y minus 1.8 divided by 0.0417. Then this will equal to now the values for Y, which will be now 1.8. So this is 1.8 minus 1.6. So 1.8 minus 1.6, what we get is 1.79. So you can also tabulate your results and you have the dimensions. Then you have FA out of C naught. Then you have you can go ahead and calculate now for the value of C. Of course, after getting this, you can go and get P, which will be now 0.56 times 3000, which is the radial load. Then you need to confirm. The radial load is 8,000. So then plus 1.79 times 3000. So what is that value? 0.56 times 3000 plus 1.79 times, we are saying it is 0.56 times 8000 plus 1.79 times 3000. So this gives us 9850. Then what is C? C is equal to 9850 times F, which is 1440 power 1 out of 3. So 9850 times 1440 power a third. and this gives us approximately 1 then. So that means this value that we have chosen, the value that we have chosen of 11200 is okay. So that means we can say the dimensions. Now we are noting the data of our bearing. So FA over C naught, we have C naught, then we can get E. So the dimensions we are talking about 75 millimeters. Remember, this is in millimeters, this is in newtons, So FA over C naught is 0.0417, then C is 11200, then C naught is 72,000, and E is approximately 0.24. So this is how you are going to tabulate the constants or the parameters for your bearing. Then you need also designation. The designation which we have seen, that is 615. So when you go to the market, you look for 615 according to what we have here. It shows that this 112007200 corresponds 6315 series. So when you go to the market, you are going to buy the bearing of inner diameter 75 millimeters, and you're choosing it from the 6315 series. Thank you so much. See us in the next lecture. Remember to subscribe, share, comment, and like.